Quality is an important concept that must be addressed throughout the value chain, beginning with suppliers and extending through operations and post-sales service. This video will provide an overview of the key concepts included in Chapter 16, Quality Management. Quality management refers to systematic policies, methods, and procedures used to ensure that goods and services are produced with appropriate levels of quality to meet the needs of customers. But what is quality? The basic definition of quality is meeting or exceeding customers' expectations. Customers can be consumers, other businesses, or even the person to whom you report on the job. Providing goods and services that satisfy customers and meet their needs is essential for business sustainability. From an operations perspective, however, the most useful definition of quality is how well the output of a manufacturing or service process conforms to the design specifications. And specifications are simply targets and tolerances determined by the designers of goods and services. But quality is not just relevant to the manufacture of tangible goods. Services must be of good quality as well, and we can define service quality as consistently meeting or exceeding customer expectations and service delivery system performance criteria during all service encounters. An established instrument for measuring customer perceptions of service quality is known as SERVQUAL, which is based on 10 dimensions of service quality performance that include reliability, responsiveness, competence, access, courtesy, communication, credibility, security, understanding and knowing the customer, and tangibles. Quality is more than simply ensuring that goods and services consistently conform to specifications, however. Achieving high-quality goods and services depends on the commitment and involvement of everyone in the entire value chain. Embedding this kind of quality focus into the DNA of an organization is based on 3 simple principles of total quality that include focus on customers and stakeholders, process focus supported by continuous improvement in learning, and participation and teamwork by everyone in the organization, since ultimately everyone is responsible for quality. The quality revolution has evolved over more than 60 years and has been influenced most by 3 individuals or gurus. The most influential was W. Edwards Deming, whose philosophy focused on bringing about improvements in product and service quality by reducing variables in goods and services design and associated processes, which will ultimately lead to higher productivity, lower costs, increased market share, long-term competitive strength, and profits. The second influential leader was Joseph Juran, who focused on increasing conformance to specifications through elimination of defects supported extensively by statistical tools for analysis. We can thank Mr. Juran for things like statistical process control. Then finally there's Philip B. Crosby, who emphasized getting it right the first time and the relentless pursuit of zero defects. We can thank Mr. Crosby's ideas for initiatives like Six Sigma. Many people view quality by comparing features and characteristics of goods and services to a set of expectations. A framework for evaluating the quality of both goods and services and identifying where to focus design improvements efforts is known as the gap model. The gap model identifies 5 ways to mismanage the creation of delivery of high levels of quality. Gap 1 is the discrepancy between customer expectations and management perceptions of those expectations. What we think customers want is often not what customers want, and sometimes customers may not even really know what they want. Gap 2 is the discrepancy between management perceptions of what features constitute a target level of quality and the task of translating these perceptions into executable specifications. Gap 3 is the discrepancy between quality specifications documented in operating and training manuals and plans and their implementation. Gap 4 is the discrepancy between actual manufacturing and service delivery system performance and external communications to customers. Gap 5 is the difference between the customer's expectations and perceptions. Here's a representation of the gap model of quality and where each of the 5 gaps are situated. We can see that gaps 1 through 4 are part of the operational focus, whereas gap 5 is part of the marketing focus, and also depends on the other 4 gaps, which, if minimized, will result in higher customer satisfaction. Many organizations around the world follow established quality standards. One of the most well-known set of quality standards is ISO 9000, developed by the International Organization for Standardization, or ISO. ISO 9000 defines quality system standards based on the premise that certain generic characteristics of management practices can be standardized, and that a well-designed, well-implemented, and carefully managed quality system provides confidence that the outputs will meet customer expectations and requirements. ISO 9000 is based on 7 principles that include customer focus, leadership, engagement of people, process approach, improvement, evidence-based decision-making, and relationship management. Another popular quality initiative is Six Sigma. Six Sigma is a business improvement approach that seeks to find and eliminate causes of defects and errors in manufacturing and service processes by focusing on outputs that are critical to customers, resulting in a clear financial return for the organization. A defect, of course, is any mistake or error that's passed on to the customer, and we can calculate the percentage of defects per unit as the number of defects discovered divided by the number of units produced. This is also known as the proportion of defects and commonly used in developing P-charts. A unit of work is simply the output of a process or an individual process step. Now, GE was one of the first organizations to implement Six Sigma and developed an approach that's now a recognized benchmark for Six Sigma implementation worldwide. It's known as the DMAIC problem-solving approach built around 5 phases: define, measure, analyze, improve, and control. In order to observe tangible results from quality initiatives, we need some type of measurement system. A common set of measures is the cost of quality, which refers specifically to the costs associated with avoiding poor quality or those that are incurred as a result of poor quality. Costs of quality are broken down into 4 categories. The first set of quality costs are prevention costs, which are those expended to keep non-conforming goods and services from being made and reaching the customer. This is essentially building quality into the process even before production begins and as early as possible, even in the R&D stage. Costs here might include quality planning, process control, information systems, and training and general management costs. Appraisal costs are those expended on ascertaining quality levels through measurement and analysis of data to detect and correct problems, and may include test and inspection costs, instrument maintenance, and process measurement and control costs. Appraisal costs represent the first line of defense in ensuring defective output does not make it to customers. Internal failure costs are incurred as a result of unsatisfactory quality that's found before the delivery of a good or service to the customer. Examples might include scrap and rework, corrective action costs, downgrading costs, and process failures. Internal failure represents the last line of defense in ensuring defective output doesn't make it to customers. Finally, there are external failure costs, which are incurred after poor quality goods or services reach the customer. These include costs due to customer complaints and returns, recall and warranty costs, and even product liability costs. Quality costs are often represented as a percentage of revenues or a percentage of total quality costs, and ideally more investment into prevention and appraisal will translate into measurable reductions in internal and external failure. There are many different approaches to observing, documenting, and measuring quality. The 7 QC tools are the simple and most commonly used. One of the 7 QC tools is flowcharts, which identify the sequence of activities or flow of materials and information in a process. Here's an example of a flowchart for an automobile maintenance shop. And now here's a more simplified example of a flowchart tracking orders through a restaurant. The next tool are run and control charts, which are simply line graphs plotted over time. A control chart is simply a run chart to which 2 horizontal lines called control limits are added. The upper control limit, or UCL, and lower control limit, LCL, are used to identify whether a process is in or out of control. Third is check sheets, which is a tried and true low-tech method of simply marking off how many errors or defects occur in any desired category. Fourth is a histogram, which is basically a statistical tool that graphically shows the frequency or number of observations of a particular value within a specified group. Histograms provide clues about the characteristics of the parent population from which a sample is taken. Next are Pareto diagrams that help us observe that most problems result from only a few causes, and is based on the Pareto principle, also known as the 80-20 rule, where, for example, 80% of quality problems are the result of 20% of identifiable causes. Pareto charts order the data from a histogram from highest frequency to lowest, and then also add a secondary scale of the cumulative percentage of errors or defects. The 6 QC tool is a cause and effect diagram, also known as a fishbone diagram, and is a simple, graphical method for presenting a chain of causes and events, and for sorting out causes and organizing relationships between variables. Finally, we can use scatter diagrams, which are the graphical component of basic regression analysis. Although they don't provide rigorous statistical analysis, they often point to important relationships between variables, such as the percentage of an ingredient in an alloy and the hardness of the alloy. Scatter diagrams are often used to verify possible causes and effects obtained from cause and effect diagrams. Another approach in quality analysis is root cause analysis. A root cause is simply the source of a problem. Root cause analysis is also known as the 5 why technique, which forces one to redefine a problem statement as a chain of causes and effects, and to identify the source of the symptoms by asking why, ideally about 5 times. Here's an example where we might start by asking, what assembly has the most defects? An analysis will determine that it's assembly number 5. Knowing that answer, we drill down and ask what the most common defects in assembly 5 might be. And the answer ends up being electrical defects. Well, that might lead us further to ask what electrical components might contribute to the most defects. And we discover that it's a K2 relay. We can drill down even further and ask, well, what's the most common cause for failure of a K2 relay? And discover that it's thermal failure. Now this example stops here, but we may further drill down and ask why thermal failure is so common in a K2 relay, which could lead us to a manufacturer design flaw. There are also other quality improvements that have been developed and refined over the years. 2 powerful approaches include Kaizen and breakthrough improvement. Kaizen focuses on small, gradual, and frequent improvements over the long run, with minimum financial investment and with participation by everyone in the organization. A related approach to continuous improvement is the Kaizen event, which is an intense and rapid improvement process in which a team or department throws all its resources into an improvement project over a short period of time, as opposed to traditional Kaizen applications which are performed on a part-time basis. A second approach is the breakthrough improvement of discontinuous change, as opposed to the gradual continuous improvement philosophy of Kaizen. Breakthrough improvements result from innovative and creative thinking, which are often motivated by stretch goals or breakthrough objectives. The development and realization of improvement objectives, particularly stretch targets, is often aided through the process of benchmarking, which is searching the industry for best practices that lead to superior performance. Best practices are simply those that produce exceptional results, are usually innovative in terms of the use of technology or human resources, and are recognized by customers and industry experts. By now, you've probably observed that quality is a relatively abstract concept, but is of vital importance to all types of organizations in order to meet customer expectations, develop sustainable competitive advantage, and realize long-term profitability. Quality clearly takes a lot of effort to define, observe, measure, and manage.